Hi everyone, Miss Moon here. I'm going to be doing the video for today on 9.1 and 9.2 scatter plots and lines of best fit. So the objective for today is I can construct and make conjectures about scatter plots and draw and use lines of best fit. So first of all, what does conjecture mean? A conjecture is like a prediction based on incomplete information. And scatter plots are these graphs that we see here where we have two variables x and y, and we plot data points based on those two variables. So let's jump into this first example. We're looking at hot chocolate sales per temperature. So for our x variable, we have temperature in degrees, and for our y variable, it's the number of hot chocolates sold. So if we look at like one point here, this point would show the data for about 64 degrees. At 64 degrees Fahrenheit, they sold about 20 hot chocolates. So let's answer some of these questions now that we've looked at the scatter plot. Number 6, does the scatter plot show a linear or non-linear association? So if the scatter plot was linear, it would have a trend in the data that is similar to a line. It wouldn't be exactly a line, but it would follow the pattern of a line, generally. If it was nonlinear, it would follow some sort of different pattern, like maybe the data goes in a curve. All right, so let's look at our plot for this example. These dots generally, except for maybe one random one, follow the pattern of a line, so we're going to say that this scatter plot is linear. Let's do number 7. Does the scatter plot show a positive, negative, or no correlation? So this basically is asking about the trend in the data. If it was positive, then as the x increases, y would also increase. But like in this problem, as x gets bigger and bigger, as it gets hotter and hotter, y, or the number of hot chocolates being sold, is actually decreasing. I mean, that makes sense. If it's getting hot, obviously they aren't going to sell as many hot chocolates. So we're going to say this one is a negative correlation. Another way to think of this is like slope. So if this was our line, the slope of that line would have a negative rise and then a run, a negative rise and then a run, a negative rise, then a run. So it's a negative correlation. Are there any clusters or groupings of data? Not really clear groupings in this one. They're pretty even. Or outliers. Are there any points that are outside of the general trends? Yes. We have an outlier. And it asks where. So this point over here is outside of the trend of the rest of the points. So it is at about 40 degrees. So we will label x as 40 degrees. And at 40 degrees, they're selling only about 13 hot chocolates that day. That's really unusual. Normally about this temperature, they're selling in the 40s for hot chocolate. So we would call this data point an outlier. It's important to notice outliers because they can really throw off your data if you ignore them. Now, these first 3 questions were asking about the patterns that we could interpret from the scatter plot. Now, number 9 is asking us to draw a line of best fit and then write an equation for the line. So a line of best fit is basically where you get to draw a line that is your best judgment of fitting the pattern of the data. So I'm going to slide this in here. And I think right about there will fit well for my line of best fit. So I draw a line, and I think that fits the data really well. This line, all of the points kind of gather around this line. So that's my line of best fit. Now I need to write an equation in slope-intercept form for the line that I just drew. In order to do that, I need to know the slope of my line and the y-intercept for my line. So I'm going to show my work on another piece of paper. Let me zoom out a bit. Great, so I'm going to show my work on another piece of paper to find the equation of my line of best fit. So first things first, I need to find the slope. So I'm looking for the change in y over the change in x. To do that, I'm going to use 2 points on my line and use subtraction to find the difference between y and the difference between x. So if I use this point up here, this point is 38.46. I just found that by looking on my graph. It's about 38 and 46. And I'll use my second point as 74 degrees and 7 hot chocolates. So I have x and y, x and y. Now to find the change in y, I'll do 7 subtract 46 over the change in x, so I'll do 74 subtract 38. When I plug that in on my calculators, I get negative 39 over 36, but I know that can be simplified, so I divide by 3 on the top and the bottom, and I get negative 13 over 12, and that is my slope for this line. Again, I just found that by choosing 2 points and calculating that slope using the change in y over the change in x. Great, now I just need the y-intercept. So I am going to use what I know so far to solve for the y-intercept. So if I have y equals my slope, which I found just barely, negative 13 over 12, x plus b, I can plug in a y that I know and an x that I know so that I can solve for what I'm looking for, my y-intercept. The reason I'm doing it this way is because on our graph, we can't actually see the y-intercept. It only is showing down to 25 degrees on this graph. So I'm going to use the equation to find my y-intercept. Well, why don't I use this point that I already found and plug it in for this situation. 7 equals, so I got that from up here, negative 13 over 12 times x, which is 74 in this example, plus b. Now when I calculate this term here, I'm going to get 7 equals, this is 74 over 1, so I'm going to multiply across the top, and I get negative 962 over 12 plus b. So now if I simplify this 1 step further, I get 7 equals negative 80 plus b. Then to get b alone, I just add 80, and I get 87 equals b. So 87 is my y-intercept. Yay, so I have my slope and my y-intercept, and I can write my equation. Y equals negative 1312 plus 87. Oops, 1312x plus 87. So for any x and y in this situation, for the line I drew, we can use degrees to find the average hot chocolate. So we'll write that answer here for number 9. Great. Now, number 10, use your equation to make a conjecture or a prediction about how many hot chocolates there will be at 75 degrees. That question was written wrong, but this is the question we're going to answer. How many hot chocolates at 75 degrees? Well, 75 degrees fits into my x variable. So if I come back to my equation, I can plug in 75 for x, and it will tell me what the average hot chocolates sold on that day. So I do negative 13/12 times 75 plus 87. I plug that all in on my calculator, and I get y is equal to 5.75. So using the equation of my line of best fit, whoops, let me slide that up. Using my equation for the line of best fit, I can plug in the x from the conjecture they wanted me to make, and I'm able to estimate that there will be about, if it's 75 degrees, there will be about 5.75 cups of hot chocolate sold. So over here, I'll say y equals 5.75, or about 6, cups of hot cocoa. Awesome. So there's our hot chocolate example. Now that we've gone through one example and kind of interpreted it and done a line of best fit, let's look at examples that could be on any scatter plot. So we're looking at types of correlations and associations. Correlation and associations are just another word for patterns in scatter plots. So over here, as x increases, y also increases, and it has a positive slope, so we call that a positive association. Over here, as x is getting bigger, y is decreasing, and that's a negative slope, so we call it a negative association. Here, there is no positive or negative sloping to it, so we call this no association. Awesome, so that's the variable associations category. You will always be able to say if it has positive, negative, or no association. In the next category, we're looking at linear associations. If the pattern generally follows a line, we would call it linear. And if it follows any other kind of pattern, we would call that a non-linear scatter plot of data. Other patterns to look at, if there's a cluster of a lot of points grouped together in a close location, we would call that a cluster. And if there's a point all by itself that's not following the other trends, we call that an outlier. So whenever you're asked to interpret a scatter plot, you're looking at these three categories and saying if it's positive, negative, or no association, linear and nonlinear, or if there's outliers and clusters. Great. Let's do this last example together. So it says the table shows the life expectancy in years for people born in certain years. So down here, the table doesn't have awesome lines, so I'm going to go through and add in the lines again so that I can see the data very clearly. So our two variables, we have x, which shows years since 1900. So if it's been 0 years, then it's the year 1900. If you were born 20 years from the year 1900, that would be like 1920. We can look down at our y variable and see the life expectancy for people born that many years from 1900. So if you were born 30 years from 1900, you would have a life expectancy, or you're expected to live to 59 years old. So we have x's and y's. Now that we've looked and interpreted this situation, we can do A, construct a scatter plot of the data, then draw and assess a line that best represents it. So to plot points in a scatter plot, we just use our x's and y's to make our points. So if x is 0, y is 47.3. And I'm just going to go through and plot these points. And you should be doing this for yourself as well on your paper. All right, so I've got my points on there. And just doing some interpretations based on what we saw in this last section, I would say that this is a fairly linear association and that it has a positive association to it, or a positive slope, and we don't really have any major outliers. Right here we have a little bit of a bump, but it's not anything too dramatic. Now we're going to draw a line that best represents the data. Awesome, so our points are gathered around that line pretty well. Part B says write an equation in slope-intercept form for the line of best fit and interpret the slope and the y-intercept. So what's great about this situation is we can use the graph to find the slope. So at 0, we were at 47 years for your life expectancy. So our first point was 0, 47.3. And let's see, the next point, we can use this point up here, 70 and 70.8. So you can choose any 2 points. I chose this one and this one. And I'm going to use that to find the slope. So our change in y, I'm going to do this on a scratch piece of paper. Our change in y over our change in x, we'll do 70.8 subtract 47.3 over 70 subtract 0. So if I plug this in on my calculator, we get 23.5 over 70, and we're just going to leave that there, but about every 23, we go up about 23.5 every 70 years. So we'll use that as our slope. And then our y-intercept we can see right here, when x is 0, y was 47.3. So our y-intercept is 47.3. And we can use this slope and the y-intercept to write our equation. Y equals 23.5 over 70 x plus 47.3. Awesome. So if you chose 2 different points than I did, or your line is slightly different, you might have a slightly different slope than I do. And that's okay. These are just estimates. Great. And then we can interpret the slope every 70 years, life expectancy goes up by 23.5 years, okay? And our y-intercept can be interpreted as at 0 years from 1900, the life expectancy is 47. Now, part C is where you're going to be able to make a conjecture using your equation. So if your equation is slightly different than mine, that's okay. You might have a different answer. So it says use your equation to make a conjecture or a prediction about life expectancy if it has been 120 years since 1900. Enter your answer on Canvas. So if your x is 120, we don't have that data on our table. But if you extended your line, you would be able to have that data. So use the equation of your line and use what you know about x as 120 years to find y, the life expectancy at 120 years, and enter it on Canvas.